Thank you. And let me welcome you cordially, and thank you for rising early to listen to my introduction. My keywords are geometry, space-time, and consciousness. I've been dealing with a science for a long time, which is called sacred geometry. It hasn't got a lot to do with religion, but sacred has to do with holy, which means whole or all-inclusive. In school, we learn about a geometry which you might say is profane, which calculates all matters of things. Sacred geometry, though, tries to develop an understanding for the whole of the whole and to try to find a language that includes all. And the interesting thing is that in geometry, there are findings or pictures that match to a hair what quantum physics and consciousness research have found. Now, let me begin with a painting, The School of Athens by Raphael. And I must say this is a relatively well-known painting. It's interesting for certain reasons because perspective is for the first time put to a definite use. You see that the lines point to one important point, which is the important one. Well, the School of Athens, that is many important philosophers that you can see and their findings. And in the center there are two who are obviously in dispute. Both of them hold a book under their arms, which is their main work. Platon is on the left, on the right there's Aristotle. And both are in dispute about where the world came from, how the world arose. Look at their hands now. Aristotle. Well, let's keep it low, yeah? Let's keep it low. That's the lower sphere. So the lower spheres and an upward development. But Plato does something else. He points upwards. He says, no, my dear, this is where life comes from. Plato has developed a book on the world of ideas, a sphere where information is stored, which is then mapped into our reality. Let us now submerge ourselves in the information space of geometry and let's see where that is reflected in our reality. Now, briefly, Plato, again, and in his writings, he spells something out. It's an old finding, in fact, namely that there are 5 bodies, basic bodies, the so-called Platonic bodies. On the left, the tetrahedron, then the cube, the icosahedra, the octahedron, and the dodecahedron. And those 5 bodies, or solids, are attributed to the 5 elements: fire, earth, water, air, and then ether or cosmos, the life energy. That's on the far right-hand side. And the interesting thing is that they are sometimes seen as building blocks of reality. And we'll see a couple of examples later where we'll see that that might even be true. Now let us now turn to this here. This is part of the larger picture. This is Euclides. And he's drawing with a compass, which is the main tool of geometry. And he wrote a book at the time, published it some 2,200 years ago, called The Elements. It was so important that it was used as a teaching document for some 2,000 years. In the 1800s, it was still in use in British schools. And one of the fundamental mysteries in philosophy is the squaring of the circle. You would have heard of that, possibly. And I'd give you a circle, and you're just allowed to use 2 tools, a ruler and a compass, to turn it into a square with the same area or circumference. We know it doesn't work. This is why we talk about the squaring of the circle is completely impossible. But in fact, there's more to it. The 2 tools, the compass and the ruler, described there, have 2 basic functions. The ruler only draws straight lines, and the compass only draws circles. You might say, okay, opposite poles, or you might say, that the circle stands for the female element, the round curved element, and the ruler stands for the male element, for the arrow-shaped straight thing. Now, if we looked at sentences, the visual sense of vision is usually described as a male sense, because we can kill with our glances, and looking usually goes in a straight line. But the auditory sense is usually the listening sense, the ears. And now try to say if looks could kill, then, well, that wouldn't work. You couldn't kill somebody with an ear, could you? In fact, the ear might even open up to the other party, but you can only kill with your eyes. There's an interesting phenomenon. In German, we have these sayings. We have got the polarity of celestial bodies wrong. We say the sun and the moon, but the sun is female in German, and the moon is male. It's usually exactly opposite, because the sun radiates light and the moon absorbs things. And usually we say if somebody is lunatic, well, that has to do a lot with the moon. Yeah, that is the fact that people are moody. Okay, and the idea that there is a creator, an original language of geometry, well, that is something that you see quite frequently, as seen just William Blake or Luca Pacioli. He's using compass and the ruler, and there's a geometric body to boot. Albrecht Dürer, you wouldn't have thought that probably, but he's quite well known here. Melancholy. You see the ball, the sphere, you see a magic square, and above the ball you see a geometric body, and you wonder which one that might be. There's discussion about that. Then Giordano Bruno, he dealt a lot with geometry, and he has drawn things like this here, for instance, too. And then there's Johannes Kepler, John Kepler, and those tools were so important to him that he had himself painted with them in hand. And he also dealt with Platonic philosophy. World Harmony is the title of the book, and a harmonic picture of the world was to be created. In the book you find the Platonic solids, or bodies, as described by Plato, and this is a woodcut here, which shows the elements. You see from the left to the right, tetrahedron, fire with the sharpest corners, then the solid cube, earthly, then the icosahedron, very close to water drops. This is why you see water elements there. Octahedron with the airy birds, and then you might wonder why the one on the right-hand side is ethereal. The dodecahedron has 12 sides, and 12 is always the element around. 12 months, 12 signs of the zodiac, 12 hours, and so on. This is what you find on the outside. And also, a pentagon has a lot to do with life energy, and we'll see that later in a moment. This is what you can see in the dodecahedron. For Kepler, these building blocks were so important that he wrote the Mysterium Cosmographicum, and this is to show the planetary orbits. This is not 100% exact, but it shows how people think. On the outside, there's the sphere, that is Saturn, the orbit of Saturn. And inside you could have a cube, and in the cube you could have another sphere. This is mathematically correct. That's not invented by Kepler. And the distance of these spheres to one another is like the distance from the inside of the Jupiter orbit, and the outside is the Saturn orbit. And of course you could further go on to nest the other planets inside. It would work out. Now let's now turn to exact geometry. Here we have a pentagon. And in the pentagon, we can put a pentagram. In the pentagram, a 5-pointed star, you see another pentagon. And again, you could find another 5-pointed star inside, and so on and so forth. So, mathematics tell us today that this is a fractal, a self-similar structure, which is self-similar or scale invariant. No matter what kind of scale you have or what level of scale you're at, it's the same structures. In this triangle, you have a large triangle, then you cut one out in the middle, then you have three smaller ones which are self-similar with a big one, then you remove another triangle from its midst, and so on and so forth. A simple example now for logarithmic scale invariance, where a certain factor plays a role from one step to another, is the typical A4 sheet. I could fold it, and that's A5, and then it's half the size. And I can fold it again, that's A6, and again, a quarter of the A4 sheet. And no matter how big the sheet, A0, A1, A2, what have you, they are always self-similar. They have always the same relationship of sides to one another. And that is a phenomenon which only works with the DIN A system. It doesn't work with American paper, I'm afraid. That is different from the DIN A system. Now, in nature, you will find that scale invariance is a phenomenon which appears in nature quite often. You find it almost everywhere. An example here, a Nautilus shell. And you can see this chamber here self-similar to this one and self-similar to the next one. So there is a certain factor which reappears from one chamber to another, makes them proportionate with one another. Another extreme example, the Romanesque cauliflower. Seen from above, you see a vortex structure, and we'll return to that and see the vortical structure in more detail. One spiral runs in this way, the other round works contralaterally, and if you look a node of the two spirals, you find a self-similar one spiral running in one direction and the other one in the opposite. And if you look at the next node, then one spiral runs this way and the other one in the opposite direction. Once you've discovered that, if you look at these cauliflowers, it's almost impossible to take the eyes off because it really draws you into the structure. And this again, if you're interested in fractal mathematics, demonstrates quite nicely how the system continues. It's self-similar or fractal. And in the course of time, science has realized that large parts of nature are always fractal in structure, and that signals can be transmitted very easily with fractal structure. You remember telephones, the big mobile ones, which are huge, and you have a huge antenna, they're not so small. And the size of the phone is only limited by the fact that we need to operate it. If it's as big as a matchbox, you cannot operate it, can you? But in theory, it would possibly be possible to build that small, because we see how nature communicates. If somebody had told you that the cell can communicate with another one electromagnetically, you might have been a laughingstock. But measuring research, that's what science does. It uses the minds, and then we end up with the same picture. We do it smaller and smaller and smaller until we reach the level of the cell, and then we realize, oh, nature has done it for ages, and we only learned it now. Well, knowledge about self-similar structures has been in place for a long time. Let's see Giordano Bruno once more. He has a tree here, and you might say the four elements around it, and a self-similar or square structure where you have a square inside and a square without. And here also the horoscope, that is Wallenstein's horoscope by Kepler, is square and a square inside the square. And geometry can hardly be done without this person here, Thoth, or Hermes Trismegistos by the Greeks, Thoth, that's the Egyptian name, and Mercurio, that is the Roman name. He's the god of writing, of wisdom, and he say something's hermetically sealed, and that, of course, has a lot to do with Hermes. He's the messenger of the gods who keeps people and the gods in contact, and sometimes he's also the god of merchants and thieves. The gods of traveling salesmen, well, you remember the Mercure hotels, and then there's somebody else who used the image. If you look at Thoth, You can recognize him by his wings on the helmet, and because he has a staff or a rod with two serpents around it. And there's a transport company that uses exactly this symbolism. And you think this is an enlightened world? But really, everybody's playing with the unconscious symbols of the mind and our history to link up with our story, history, evolutions, and the good feelings that arise from that. This is what I found in Zurich. This is from a bank building that is above their main entrance door. And then there are the hermetic laws by Todd, and we find one, the principle of correspondence and analogy, as above so below, as without so within. You will have heard about that, but this is exactly what we're talking about. Geometrical structures which are nested or repeat themselves. And this is how it is expressed. This is a drawing for a cathedral. The cathedral should map man, or should reflect and represent man. And now, if we take it from a philosophical point of view, church is to get people in contact with the divine. If you want to achieve that, human geometry and divine geometry are the two factors that you have to know. And since Leonardo, we know about human proportions. That, in fact, has become a science of its own right, in its own right, something that people have dealt with over and over again. And here, the masters who dealt with the science used these stonemasons' marks. There are lines and straight lines, male and female energy for you. If you want to decode them, you have to understand that stonemasons have so-called signs, which are the 6-lobe and the 4-lobe traceries. Here we have squares and circles, and we have nested inside them, again, 4 circles and 4 squares. If you put the stonemason's mark there, you can see where exactly the stonemason's mark go. All these marks can be derived from these traceries. Now, let us now go to Egypt. There were mystery schools which initiated people into the fact that there's just one consciousness, that we were part of a single reality. The reality was just there to make us experience certain things, but that we were never really separate from one another. Sacred geometry uses 2 tools, the circle, the compass and the ruler, but we also need to have a blank sheet. If we used squared paper, then of course we'd leave the paths of sacred geometry, because each measure must develop out of itself. If I simply said, well, this line has to be 5 centimeters, well, that wouldn't be correct, because human consciousness, human perspective would enter into it.
If I have white paper, blank paper, well, everything that I do should come out of itself. If I draw a circle, that's like a consciousness sphere or a path of consciousness, and even a line is like consciousness moving from point A to point B. All the religions know the world tree, or the navel of the world. The closed circle, the pen, is considered the axis of the world, and the point where you start drawing is the navel of the world. And if you do a drawing, an artistic drawing, like you have a white piece of paper in front of you, you're a creator in that moment. You could actually take something that exists in your imagination and make it material that moment. You can actually draw a draft of an engine, you can write a love letter, you can draw a house, whatever. You're the creator, but there's a beginning, and that's the navel of the world. And if you take a compass and you open it, geometry says that we're now creating space. We extend, we stretch, and consciousness extends and stretches, and that's what it looks like. And it doesn't matter how big the circle is. Like, if I actually keep this presentation small in a small room, it's small. Here it's a big room, so it's a big circle. It's like our basic measure, our original measure, and we could show that this knowledge existed in Egypt and derived, we can find it in the holy scriptures of the world. Once you understand the language, once you can read it and you find the same thing all over and over again. Simple example. In Western culture, we're saying in the Old Testament, there's Genesis. And in the beginning, God created the heavens and the earth. We have no limit there, no line, but now we're creating a structure, a line. And then we can say, in the beginning, the drawer created an inside and an outside, a border. And over the centuries, it turned out to be that, but in the beginning, God created the heavens and the earth. And the earth was formless and void, and darkness was over the surface of the deep, and the Spirit of God was moving over the surface of the waters. So consciousness could be right in the middle of it, and consciousness wants to experience itself and wants to experience what God created. So it goes to what was created new. In this case, the circle, the limit. And the Spirit of God was moving over the surface of the waters means the consciousness moves to the surface, does whatever it can already do, it knows how to do it, so it draws another circle. This doesn't have anything to do with creationism, something like that. It's just trying to describe how you can take the geometrical perspective to show how an earth was created. This is the first day of creation. A bladder of a fish, or vesica piscis, that's what it's sometimes called, which is the overlapping of the two circles. Let's go back to Genesis again. It says, then God said, let there be light, and there was light. Now we could ask, what does this drawing have to do with creation? Well, we have two circles, geometry, female, but there's 4 points that matter. The two intersections outside and the two centers of the circles. And if you ask a physicist what light is, he might just say, well, light can be considered an electromagnetic wave. There's an electrical component, and perpendicular on that, there's a geometrical component. And if you then take those 4 points and you connect them, you get an axis, just like the mechanical structure of the light. But you can also take a different approach. From the drawing with the pentagon, you saw that we have nested structures in geometry. In the fish bladder, you can see 2 triangles that are back to back, and even in them we have 2 equilateral triangles back to back, and inside them as well, and so on and so on. So we can learn something by actually analyzing light itself, or we can learn something by actually looking at the recipients of light. Think back home. You want to listen to a radio station, so you take your receiver and you switch to the station in order to go into resonance as good as possible. Before you did that physically, you had like this knob in order to tune in those two, and if both are in resonance, an information transfer can take place. So we can learn something about the structure of light by looking at light recipients. And this is what it looks like in nature. So when maple tries to grow into light, it's trying to adapt to the structure of light. We have the leaves here that are perpendicular and perpendicular and perpendicular again. This plant does it the same way. The maple leaf was like 20-30 centimeters big. This is 2-3 centimeters. And in philosophy, there's a statement saying something like, man is the measure of the universe. It's not man is the measure of all things. Somebody got that wrong at some point. It's man is the measure of the universe. And if you have a holographic structure that's self-similar, you can take some subject, some object from the universe and look at it and learn something about the structure of the whole universe. So let's take a look at man, at humans. We also have light recipients here in men, and that's what they look like. And the geometry of light, we can continue to analyze it further. And then what we see is this. It's the ball of the eye, the iris, and it's the pupil in the middle. And then it doesn't matter what creature we're looking at. We're all using the same geometry. Looking into the light field to perceive it, to decode it, just like in a frog, in a cat. You can see it all over the place. You can also see it in the complex eyes. Here it's a little more complex, you could say. Yes, it may be so, but even if we zoom in on them, we can see that this is a hexagon structure that's imitating the structure of light. to go into resonance with it. But it doesn't stop here. There's more meaning to that symbol that we find in the first day of creation. Here we have the cathedral at Baal. Here we can see Jesus in that case, with a halo in the background, and that's the manvala. Manvala, that's the almond shape, but it's also a gate that's opening. A new consciousness comes in. That's also how we could see it. And often it's shown like that in medieval writings. Unfortunately, I didn't bring a picture, but you can also get it with Mary and other saints. You can certainly observe that for yourselves. And if we just go back to the original, the circle with a point in the center, this is the ideal center. We have one form, we have harmony, but still consciousness tries to divide, like two pieces. It's all about two things. Dilemma, two. There's also like trouble all over the place, but we also have wholesomeness, twosomeness, and so on and so forth. It's like a non-stable, an unstable state, the number 2. But still, consciousness decides to split up and become 2. Usually you're adding 3, like you're saying a tripod will never wobble, or something like that, creating stability if you add another one, if you have 3. But in this function, we could also say this. Consciousness goes out of unity to step into a new world. And there's also a gate. The things that I'm saying here, they exist in my mind, my spirit, and through a gate, they step into space. Check the geometry of the mouth. You can see that it's like the bladder of a fish, the same kind of gate that you can see here. That's where Christ's impulse moved into the well, or something else. And we always have nests in geometry shapes. We have one bladder, we have to have a second one at a perpendicular angle to it. Check the mouth of your neighbor. You can see 2 bladders of 2 fish, basically. And all of us, we're pure geometry, inside and out. We're following this law of nature. You couldn't have come in here, you couldn't have come into this room without knowing the laws of geometry. And the human body has another mouth, the vulva in women. And the opening of the vulva, the gate that brought you into the world, is this picture right here. And for that reason, the overlapping circles, this drawing is often used by female cults in order to show that they stand for the creative power, the female element that gives birth to life, that brings life into the world. And that's basic structures derived from geometry. Right. If you want to go for mathematics here, you can see the 3 basic roots in ancient Egyptian mathematics that happen in the first step, the very first step. 1, 2, 3, and 5. We need the root of 5 for the golden ratio. But let's continue with pictures here. Let's imagine that's soap bubbles that we see right here, these 2 circles. And now we tilt this by 90 degrees, and we look at it from the top. And that's what it looks like now. And here we have a new measure that we just created. It's the overlapping of the 2 circles right here. And the rule was, go to whatever is new, we're curious, we move towards the new, and we do whatever we have already learned to do, which is we draw another circle, which means consciousness has moved to here, and the next step probably is going to move here, just because there's a new measure. Try and find out what happens there, and draw another circle. And that's what it looks like. We would say it's the second day. On the second day, once again, we have female energy, we have circles, but we can add male information and combine it. Like we're drawing a big equilateral triangle, and you can see that every line goes through an intersection in the middle, like here. And here we can add a small equilateral triangle. And if we look at that, we now have 4 equilateral triangles. And the 3 triangles could be folded up, and then this is what you'd get. It's the tetrahedron. It's like a triangular pyramid. information from the second day of creation, geometrical creation. Let's just remember that. We'll go back to that in a minute. But, you know, that's a perspective. The movement of consciousness doesn't stop here. We'll move into that intersection. Then we call it the third day, that's the fourth day, the fifth day. And if you have a good circle, it's really fascinating to see that. At this point, that's where 3 circles meet in 1 point. We have to go back there again. And if you ever wondered why creation has 6 days, you can see that it's a geometrical description or mission. And on the 7th day, he rested and contemplated his work and saw that it was good. But it doesn't stop here, not even here, because each circle corresponds to a sphere, and here we're switching between dimensions. And you can certainly imagine this. The circle in space is a sphere or a waveform, a propagating light wave, whatever you might want to say. We went to the surface and we moved all around, passing 6 stations. But you could ask, what kind of a form is that movement of the sphere, of the circle around that center circle? And there's a geometrical trick that we can apply. Within that bladder, we draw a connecting line, and then we dip right into the middle of that circle. We draw a new circle. I'll just eliminate the inner circle. We don't need it now, but it's still there. Doesn't matter what circle I draw, I always move on the inner circle. And that's what it looks like. That's the next step. And let's condense that even more. Let's draw some more circles and even more circles. You can certainly go back home and use your compass to do it yourselves. And mathematicians would say, well, that's a torus. Think food. You could also say it's like a bagel or a donut. It's a hoop with a hole in the middle. Let's use our computers here. And that's what it looks like then. And so that you have a special sense of it, we'll tilt it slowly. And that's where we land. That's the form of each magnetic field. If you have a little stick magnet, there's magnetic field lines on the top and at the bottom. Or like here, the marble in the middle, that's our planet, and the field all around, that's the magnetic field of the Earth. Doesn't matter where you look, you'll always find the same structures. Let's move on. That's what it looks from the side. 1 vortex at the top, 1 at the bottom. And let's now look at a tomato or an apple. On top we can see a vortex, and we can see 1 at the bottom as well. Let's look at a tree. The tree will absorb nutrients from the ground, moving it into the leaves or the fruits, and at the latest in the fall, the leaves fall down again to become nutrients to move up again. So we have a torus circuit that's shown here. Same thing applies to butterflies, for example. The wings will always be flapping in the torus field, and in the middle it always looks like antennas that control the field. And look at the apple again. Like I said, we can learn something about the universe by analyzing man. We can also learn something by analyzing an apple. Let's take the apple, let's cut it open like that. We can see it's a torus. If we cut it like that horizontally, we can see that we have a pentagon in the middle. And here we have like a condensed field, and we have more condensation. We have a pentagon inside, and on the outside we have 10 vertices, but not all use 5. Tomatoes use 2 or 3. The cucumber, I guess you've cut it thousands of times, but you never really watched out for that. It's the number 3 again. And this is really interesting. It's a holographic structure. The fruits also have a memory. The apple is the fruit. And before the fruit, we had the blossom. And if you cut the apple open horizontally, you have a slice, or half an apple, and you cut a thin slice, you hold it up against the light, and you can see the blossom is still here. And we actually derived a little bit of information from this simple pattern, but it doesn't stop here. There's new intersections, so we add more circles. And even here we have a 3D information inside. But I'm not changing anything about the measure. I'm only erasing a couple of lines to make it clearer exactly what happens. So this is what happens. That's what it looks like. In geometry, we're calling it the egg of life. But it's a cube. consisting of 8 spheres. And once we've reached that point, it's worth the while casting a look at this, a look at how we came to be. We're all starting life as an egg cell, as a sphere. Doesn't matter what kind of life you're looking at, everybody starts as an egg cell. It all starts with an egg, whatever creature you may be, frog or whatever. Inside there's different structures, and here I'm simplifying things. We have a nucleus, 2 centrioles, and now the set of chromosomes has to double. And then the central bodies send fibers that pull apart the DNA, but before they do that, something really exciting happens. The chromosomes, they order in the shape of a star with 46 points, like in the apple. And we call this the mother star. But it's the very same thing. Whatever we see in the apple can be found again in the inside of a cell. Wherever life divides, we have the same patterns, the same pathways. The fibers pull apart. On the top, we have one set of chromosomes. We have one at the bottom. We have invagination, and we call this the first day of creation. When the 2 cells divide, we have 4 cells that develop. And usually that's shown as 4 points that form a quadrangle, but if you try and make 4 spheres a quadrangle in space, it doesn't work. What happens is these 4 spheres form a tetrahedron. And the 4 spheres, when they divide, we have 4 new cells, which gives us a total of 8, and we have the egg of life. And of course, creation doesn't stop here. We know a lot about the geometry of man, and in Leonardo, this is what it looks like. We're just as tall as we're wide. The span of my arms reflects my body height, and this square of 4 body cells is at a point where we have our genitals. So if you want to find the center of your body, you draw 2 diagonals and you find that point. A perspective of the first 8 cells at the bottom is the view of a cube, a quadrangle, and geometrical patterns are always nested. The first 8 cells have a field that they emit that's nested from the inside out. And at the end, you get the structure that we're growing into, the square that we have all around ourselves. If somebody actually says that you're as tall as wide, don't get nasty with him. Be nice, because he paid you compliments. He said, you are in perfect harmony. And development doesn't stop here. You can consider a torus a sphere where the top and the bottom pole have connected. The cell shell has become dissolved. Now we have the first 8 cells still here, but they're getting invaginated like that, all the way to the bottom. And that's what it looks like. And simple creatures would stick here. Polyps actually would use that as the mouth and for excretion again, but in humans it's different. We get a vertical axis, and that's the placenta. That's going to be the placenta. This is going to be the navel cord, and at a right angle to the main axis, just like an apple, new life forms. The nervous system, the embryo, is going to develop. And we can also learn something by looking at the egg of a chicken. If you look at the egg white, you can see a cord, like a fiber inside. And that's the umbilical cord. And if you look at it under the microscope, this is what it looks like. And if you continue to look at it, it was pretty difficult to take a photo of it because the vortex is pretty big and it's getting condensed, it goes down, and that's what it looks like in nature, outside, in a storm, for instance. So you can see the structure is always the same. And the point where the vortex goes, this is like a hurricane, for example, and in people, we also have something like that. And it's our navel. Looks like in an apple. This is where the vortex once went. But you know, when the child is born, the navel is right in the middle of the body. And you can also do a rough schematical drawing, navel in the middle, and then you have a vortex structure to both sides. This is a melon. You can see it very nicely. This is where the life energy comes in. This is where vortexes form. And this could be like the head, this could be the legs. Then the baby is born, and the life energy, the main supply, happened via the navel up to that point. Then the baby takes the first breath, and then the energy supply switches over from that axis to the perpendicular axis. We then start absorbing energy from the top and the bottom, and that's what it looks like from the top. And in people that have more hair, it looks like that. So even here we can see a reflection of the structure of the information behind. And that's what it looks like in the universe. Wherever we look, as above, so below, we have the same structures. And there's a riddle. Like I said at the beginning, it's the squaring of the circle. We know that we all have a square around us. And if I stand up in front of you and I stretch out my arm like that, there's a point that I can reach. But that's how high I can get. I can actually try, but that's all I can reach. And the measure from there to the ground is equal to the diameter of the circle that I was drawing here. And this circle has the same circumference as the square that we have around us. So we have the squaring of the circle. Circular equation right inside us, but it doesn't stop here either. Inside the square we can add two spheres. One sphere fits the square perfectly, and the second sphere is the one reaching from here to here. And this part was added up here, and those two spheres, those two circles, have the same ratio, just as the diameter of the moon and the diameter of the Earth. If you don't believe me, take your pocket calculator, diameter of the Earth times 4, circumference of the circle, then you have the formula here, and you get 50,925 kilometers. We're talking about geometry, right? So we have to also mention the golden ratio. I'm using a segment, calling it C, divided outside of the center, and then I get a short A and the long one B. And the golden ratio is taking about where I need to divide so that the ratio long to short, A to B, is equal to long B to C, the full segment. And if you do that, you have a certain mathematical measure. In order to stick to the pentagon, this segment is actually divided in the golden ratio here and here. And we're saying this is the short part, minor, and major, that's the long part, the long segment. The baby is born, the navel is in the center, we said that, and the navel, of course, shifts, it moves. And today the navel is exactly in the golden ratio of the human body. But the navel, if that's the golden ratio, and this is the middle, there's also a golden ratio at the bottom. And if I'm relaxed, you know where my fingers end, that's where the golden ratio at the bottom is. And I can also show you that the fingers are divided in the golden ratio. The whole body has the golden ratio all over it. And if we take a square, we started with a circle, standard circle, we could also say standard square. We draw a diagonal, we use a compass, and we put a circumference over the basic segment, so we have a length 1.68033 and so on and so forth, which we call phi. And that's the measure of the golden ratio. Here at this point, that's where we have the harmonic ratio of the golden ratio. And if we do it up, we have a golden rectangle. Let me not give you the mathematics, but we can cut off the square, and here a rectangular part stays behind, which is another golden one again. You cut off a square again, and we still get the same thing again. As a result, we have a golden rectangle. You cut off a square again, and you get the same result again. Cut away again, and you always get the golden rectangular section, and you get something like an approximation to a golden spiral, which is a little different, but it's very close to it. And that's the structure that we see in the Nautilus shell or in the galaxy, like here. And if you still feel like you have no business in mathematics or geometry, let's take a look at genealogy, the family tree. We know it from the cell division, 1 cell, 2 cells, 4, 8 cells. You're up here, you're the happy person, and you have 2 parents, and your 2 parents have 2 parents again, and they have 2 parents again, and that's what it looks like, 1, 2, 4, 8, and so on and so forth. And if you've ever tried to look at genealogy, it can be quite complex to understand the situation. But, you know, you can be so happy because you know B. That's the family tree, the genealogy of a bee. The queen will lay eggs, and if there's no fertilization, there's going to be a drone that comes out. And if there's fertilization, there's a female queen again. So let's start here with a man. There's only a female as an ancestor, with a male and a female. So the female has 2 ancestors. And then you have the sequence of numbers that you can see on the right-hand side. 1, 1, 2, 3, 5, and so on and so forth. In people, it was different. It was simple. Multiplied by 2, by 2, by 2, by 2. In the bee, it's different. 1 plus 1 is 2. 2 plus 1 is 3. 2 plus 3, 5, and so on and so forth. So each number is a result of the subtotal of the 2 ancestors, predecessors. And there was an Italian mathematician, Fibonacci, so it's called the Fibonacci series, and here you can see him, that's a picture. But if you want to look at the ratio of 2 consecutive numbers, if you want to calculate that, you can see the right-hand side, the blue numbers, 1, 2, 1.5, 1.66, 1.6. And the step between 2 is getting smaller all the time. And then in the second but last row, you can see 1.618, and that's the number of the golden ratio. It's kind of a dampened oscillation. That's how you could see it. Let's look at the sunflower, for instance. If you look at that, you can see counter-rotating spiral, one moving that way and one moving that way. And we're counting like how many seeds there are in one spiral and how many in the other spiral. It's either like 2 Fibonacci numbers or 2 that have the golden ratio vis-a-vis each other. We saw that before. Same number sequence here. And you keep listening to me, at least I hope so. Let's check the inner structure of the ear. We can see that we have a golden spiral right here. That's the receiver. You have to breathe as well. So here we have the lung. We have 2 lobes in each lung. On the left-hand side, 2. On the right-hand one, 3. Either you're a musician, you're saying it's a quintet, or you're looking at the Fibonacci sequence. Then you can see that it's 2 numbers from the Fibonacci series. And it doesn't stop here. A child has 4 times 5 teeth. And when you grow up, you have 4 times 8 teeth. And there's an old wisdom that says something like, God is sleeping in the stones, breathing in the plants, dreaming in the animals, and wakes up in humans. And that's how you find all the structures reflecting in people. You have the stones in the crystalline bones, animals in your blood, maybe. And here you can see it again. We have the same sequences, just like in the plants, even in ourselves. And it's the egg of life again. Remember, it's 8 spheres and a cube. And you also know it from music. From C to C, that's 1 octave. And that's 8 white and 5 black keys. And chemistry, the periodic system, is reflecting the structure of the atom.
We have the first main group, and so on and so forth, up to the 8th main group. That's the next octave then. So noble gases are part of a different octave, and they feel too noble to communicate with the first group. But let us now look into the internal structure of the DNA. We have a DNA-shaped building after all, and you have a double helix, It's as it were, and it is self-similar again, at least in this picture. And if we take that line, it is a spiral again that consists of a spiral again, and there's a spiral inside again, same as in the Romanesque cauliflower. And the sequence of 4 base pairs describes one amino acid. So guanine, for example, that is one possibility. We have 64 variants. The DNA, however, only uses 20 or 21 plus 2 start and 2 stop codes. But if you calculate that, 4 possibilities in the first position, another 4 in the second and third, that gives you 64 variants, and you find an 8 by 8 square. The number of 8 begins or doubles on itself again. And the I Ching from China is 3,000 years old or older, and it is like the blueprint of reality, the book of changes. And it describes the reality in 8 by 8 possibilities. And that is the same that we find in the DNA, if you want. However, the I Ching has 64 possibilities. Every variant is interpreted, although we, with the DNA, haven't gotten that far. But maybe it's just that we don't understand DNA properly yet. And the vertebral column also has 64, and so, again, 3 times 8. And we do talk about vertebrae, where you find the word vortex again. And if you look at the brain, well, that is a vortex opening up. Or if we say we have a torus inside, well, then the brain would be as the antenna of the butterfly in the vortex of the part and would control things. We're back with people now. People are said to be harmonic, or you might say it's the representation of the number of 5, the head and the 2 arms and the 2 legs. You will remember this here. Structures are self-similar or scale invariant. I have this from my home area. We're on a rock looking down, and you see one piece of rock, and then you see more rocks further out. Well, our ability to gauge distances, well, that is logarithmically scale invariant. Well, if I try to estimate how far away I'm from the microphone, I may be 1 centimeter out. If I look at the end of the room, it would be 1 meter, and that here, I couldn't tell. It might be 10 meters or so, and further out it would be 1 kilometer in accuracy that I can get. The further away I am, the less accurate in absolute terms I am, but relatively speaking, it's the same scale, the same invariance. Same with our hearing sense. Our sense of hearing is also logarithmically scale invariant. Here we have the Weber-Fechner law that bears that out. You find that as you estimate distances, your hearing acuteness, your visual sense, your sense of touch, your sense of smell are all subject to this. Our senses are logarithmic because the world is logarithmic. The world is logarithmic or scale invariant, which is the basic structure of these things, and our senses just observe that and have adopted the same measures. An example here, this is a graph which shows how the planets are arranged. The baseline, you might say, is given by the sun, and the further up the planet, the greater the distance. That is, the further away we are, the greater the distance. And you can see it's a hyperbole. If we calibrate that, then we end with this, which would be a straight line in a logarithmic room. The structure of the universe, that it's logarithmic or scale invariant, that is captured by the globing scaling theory. And it's basically the same as sacred geometry. Scaling is scale invariance, and global, that's the universe. And, well, it's been discovered in particle resonances. It's been found in the fine structure of particles, and you always find that in the structure of organisms and how they vary in size. It's all been summarized in the global scaling theory, which gives you a picture from the very small to the very big, and then that means that there's just one background wave which influences all. Today, scaling has been demonstrated for elementary particles, for the microwave background radiation, in physical random processes, in the atoms, in crystals, and so on. But why is it so? Why is it that all nature is logarithmic in scale? Now, if you have a vibrating string, it always has an eigen vibration, then you always have one basic tone or harmonic. Then there's the first, second, fourth, fifth, and so harmonic. Now let's draw that. This is the first harmonic. This is a magnification of a string that vibrates, and you can see what happens. This is the 20th harmonic. And all sounds start here or here. In a guitar, you have a board in the beginning and the end, and everything between that must be integers. There are some numbers that go through the middle, and there are some numbers that avoid the middle, even and odd numbers. And let's say we don't take the odd numbers for this experiment, and this is what you get. Even numbers. Some numbers are divisible by 4 and others are not, and those are not divisible by 4 are removed, and this is what we get. And again, we continue, and in the basic structure we have the half string length, and musicians understand that that's an octave, the quarter, that's the next octave, and so on and so forth. In a vibrating string, we always have a fractal structure with octaves nested into one another. You might say there's a background wave which vibrates, right, with certain intensifications, and which is fractal in structure. So we can be in a very small world, but we could also go out into space, and then we'd have larger amplitudes. Now let's look at this photo. It's a castle in Dresden. And if we enlarge it, and you think it's a castle, isn't that? Let's now enlarge it. You remember that, yeah? It's a castle. Well, and that's the resolution for you. But if we looked at the monitor in more detail, this is what you'd get. It's the background matrix, and that's the matrix on which I've given the presentation, and I've picked up some elements from the background matrix, and that's what reality is like. A grid where we're inside, everything is interconnected, and we just pick out information. And let us return to the Genesis pattern, or the torus for that matter. Well, of course it doesn't end there, does it? A circle can be understood as a wave, a photon or a light wave propagating, and that would be the next steps, and so on and so forth and so forth. An endless pattern, which is so finely structured that at some point you don't detect this pattern anymore, just as you can't see the pixels of the monitor. And then you end up with this here, which went through the internet shortly, the Earth, the solar system. The Earth is, there's a moon circulating it, the sun. Now, planets around it, then there's a galaxy with other things circulating around it. So no matter what level, it's the same pattern. And I found it amusing when I got the invitation. EMBL, did you see the logo? It's an arrangement of circles in this six-sided structure, hexagonal structure. This is called the flower of life, and it is a symbol that you will find everywhere in holy or teaching or training places. Here in India, for instance, in the vicinity of this temple, that's what you find. Okay, this is Croatia, excuse me, Romania or Crete, the Isle of Crete here. Just a few examples to demonstrate that this is a global phenomenon. And if we assume that people were just a physical body, well, that's not the whole truth. We have a field around us, a field with which we scan reality. Let us now ask a painter with special sensitivity, Alex Gray, for instance. Well, this is his picture, a vortex in several places, and then he calls that the mental level, and that really gives us the aspect of a torus. We know that the field of the heart has a size of 9 meters. It is torus-shaped too. The fields around the head are torus-formed as well, because all fields are torus-shaped, and this is what it looked like in the past. These are fields around the head, but people just couldn't describe it in any other way at the time, I suspect. In the end, this is what we come up with. This is what you'll find in some esoteric schools. People have an energy field around them, and it has a small and a large field, a sphere, and a torus field around it, and that's how we are located in the large matrix, right? We move in the large matrix in this shape, and what we perceive as reality, what we see as firm, the wall, the table, that is just a standing wave in this information space between those two balls, or spheres. Brain research has evidence that, how do I put it, that there's a small time lag between the beginning of an action and the decision or perception of an action. So let's say in every moment we project the reality that we perceive, we project it outside, and only then do we perceive what we've seen. And we are creator and observers at the same time, but only we don't notice, we don't realize that. You might joke and say, we don't see a tree. We just agreed that there is a tree. Well, of course, a tree is still a beautiful thing, no doubt about that. This is just to show you how we may possibly create our own reality. Let us now look at the background matrix, and it fits quite nicely into this room, doesn't it? It's round, and we are looking at the outside of the sphere. There's some information that comes in, some information that you absorb, that you realize, and let's put it simply. Thank you, it says. Thank you.